Hello and welcome to another video from Ellensburg Amplifier Repair and Service. And today we have a B2 audio here that, I'm sorry, it's not a repair video. I'm actually putting this back together. Let's see what this is. This is the B2. Oh, yes. Yeah, this is the B2 M1s amplifier. So this came in for repair, and the reason why I am making this video is I just wanted to kind of go over thermal paste. Someone had repaired this in the past, and they did a somewhat decent job of the repair itself. There's a few things that I went through and kind of touched up. There's some burnt PCB areas on the power supply with some burnt vias. So of course I did my little dental work to the board and got it all taken care of. I don't know if you can't quite see it on the video here, but I did repair the vias and the PCB here at the bottom of these drivers, and I also did the vias of a couple of power supply transistors over here. So at first, when I originally got this amplifier in, I was showing just shorts. I quoted it as a shorted amplifier, and the funny thing about this particular repair is once I slid this out of the heatsink, I no longer had any shorts. Why? Well, we'll get to that here in a second, but I don't know if some people don't understand the actual functional theory behind these amplifiers. So I don't know if the previous repair person did this or not, but the output transistors on this amplifier happen to be on that kind of like Play-Doh consistency thermal strips. This was a full strips, kind of like it's almost like a Play-Doh. I really don't know the name of those insulators yet. I've been trying to find who is distributing that, who's selling it, but I don't even know the name of the stuff. So, but when I slid this board out and I didn't have any shorts left, I started scratching my head going, well, hold on, how come I don't show any shorts now? Well, as I was cleaning up the transistors, getting ready to remove them, thinking I had a short, I noticed that the original thermal paste had a really serious metallic look to it. It was almost like a copper color. So I took my meter and I read across where the thermal pads are on the heatsink itself, and I read continuity across the mating surface of the thermal insulators. So whatever thermal paste they had on the amplifier was actually shorting the board out. I don't know if the original complaint was, no sound, or he just sent some pictures of the board that needed to be some burnt areas. So I don't know what the original issue of the amplifier was, but if it was given any problems, it's because the transistors had thermal paste that was electrically conductive on it. And the back of these transistors are what I call, I mean, remember I'm a retired electrician, they're live. There's voltage on the back of these transistors. And on the for the output section, you have rail voltage. So it's very, very important to isolate these transistors off of the heatsink to prevent shorts. And trust me, I have done this before, where I did some, I think it was like a Tar Amps 30K, and I got it all back together. Well, come to find out, I forgot an insulator. And when you forget an insulator and you fire an amp up and that rail goes to ground, it really wreaks havoc on the little filter capacitors. It's kind of off camera here. I can't quite get it on camera for you, but let's see here. Yeah, just barely. You can see a little filter cap right up in the top right hand corner here. That filter cap is going to ground. So if you have a rail short to the chassis, 9 times out of 10 that little capacitor will burn up. So I don't know if this amplifier just had running issues due to the thermal paste or what, but I'm gonna get it all put back together and put it on the old load bench because it fires up. 50 hertz input signal, 50 hertz comes out, power supply, all the transistors stay absolutely cool, so I know there's no thermal runaway on the transistors itself. So I'll get it all fired back up, or fired back up. I'll get it all put back together and then get it all fired up and run it through the test to see what's going on with this. I don't see anything wrong with the signals, with the switching. It's the IRS 21844 ICs on the output card that this uses. This is kind of a bigger amp, and I don't have my other camera, but you can see the output card right there. It's got 4 IRS 21844 ICs on it. Just another typical, but we call it Korean design. So used in, good lord, just a huge line of amplifiers. You'll find this particular drive. So I ripped off all the old thermal pads, got rid of all the old conductive thermal paste between not only the power supply and the output section, and got new thermal paste applied. New insulators are installed in the output section. So I just wanted to bring it to everyone's attention. If you're putting an amplifier back together, don't use conductive thermal paste. That could lead to a bad day for the amplifier. You want electrical isolation between the transistors and the heatsink. You want that isolated. You don't ever want them to touch. Unless, of course, it's a full plastic body transistor, like the rectifiers here. These are full plastic, so as you can see, there's no insulators behind it because they are insulated already. So please don't use conductive thermal paste. Research your thermal paste. A lot of these thermal pastes are electrically conductive, so be careful with it. And thanks for watching. We will catch you on the next video. If you have any questions, leave them down below. And as usual, stay safe. Keep your fingers out of the rails. These voltages can be quite high. We'll catch you on the next one. Thanks for watching.